It's me again. Now I get to talk about Fluence. So welcome again. We're going to talk about a new staking model. And Fluence, I got to explain first to people who don't know what Fluence is. And we do something sort of similar to what Mark is talking about Ether, but there are kind of key differences I think you're gonna discover. So first, what is Fluence? It's a cloudless compute platform. And what is cloudless? It's decentralized, it's resilient, low cost, and verifiable. That is important. It's important because it's not just a marketplace. And there are a variety of marketplaces out there, but to actually compete and to scale, you have to do more than just be a place for people to find compute. You have to have that compute be resilient, and you also have to productize it in a way that makes it easier for consumers and enterprises to use. I know that's something that Ether has certainly focused on, and I think everyone is discovering that. And so why cloudless? What are these? I mentioned these words before, but what do they mean? Decentralized doesn't mean you need to have 50,000 people running compute. You can have 30, 20 top-tier data centers running the compute. As long as no entity controls it, it's decentralized. Resilient, self-healing from failure is very important, so there's not a single point of failure, and the network can keep operating, and your compute can keep operating if there's a failure. Low cost. We think Fluence will be about 80% less than the centralized cloud. That is very important in terms of adoption. Verifiable, you also want proof your compute was performed. And then last, this is a terrific attribute, but there are green data centers that are part of the Fluence network. So you can actually select to have compute be performed by completely renewable energy, which is, again, not an easy option in the centralized cloud. Why does cloudless matter? Well, it matters because between Google, Amazon, and Microsoft, 60 to 70% of the cloud is kind of dominated and controlled. And that number continues to grow. And they grow because they actually provide a valuable service, and they do it well, and people use it. No one is forced to. But that comes at a price. And the proprietary platforms are difficult and costly to leave. And when someone leaves one of the clouds, it takes a long time and a lot of money. And you get lured in early, and then the price just continues to rise over time and becomes very expensive. There was stats some time ago that, years ago, 14 to 15%, 14 to 15 cents of every Lyft ride went to Amazon. I'm not sure what that number is right now, but it's material. They also have the ability to deplatform and censor users. And as they are very big, they make those decisions by themselves. The terms of service agreement at Amazon that you sign is something like 60 or 70 pages. So that can be interpreted any way, whenever they want. And they don't even have to deplatform, but just that threat provides a real chilling effect on a whole number of businesses. As these businesses get bigger, they inevitably become much more closely tied to governments. And that is also something that I think people are seeing as well. And then finally, these ecosystems are each closed. You're on Amazon, you can't easily interoperate with Google Cloud or with Microsoft. And so you're constrained by what you can do, by what data you can share, and that closed ecosystem stifles innovation. So, and the sort of secret is, which we don't like to talk about, but almost all of Web3 relies on centralized clouds. Right? And so Infura, which is a critical component here, still uses cloud. And there's a decentralized initiative that they are working on, which we're very excited about, to help remove that centralization. But top Web3 projects still use Amazon because we don't yet have decentralized compute. We have decentralized payments. We heard about decentralized storage from Molly, and decentralized compute, like as Mark talked about, is the next sort of final thing we need to do. And if we don't do that, then the other parts of Web3 matter a lot less because we're still stuck using the cloud. There's still that single point of failure. If you can shut off the compute, you shut it all off. So we need to have decentralization in the compute, and that's the hardest thing to do. But why does cloudless win? Well, if you have an open platform with no protocol fees, it's transparent, and there's transparent and costless switching, or almost costless switching between providers. That is very powerful, because it allows low cost and allows you to always be shifting your compute to where you need to do it, or never shifting it, but it's your option to do it. Also, because you can shift your compute, that means there's no pricing power from the providers. And if there's no pricing power, it's commoditized, and price goes down to basically the marginal cost, which would be electricity, maybe some amortized capital cost, depending. So when you create a architecture that allows resilience and allows very minimal switching costs, by definition, you're going to compete those costs down and eliminate the pricing power of those providers. And that is that is sort of a foundational component here of why we think cloudless and resilient decentralized compute is the future. And then finally, when it's open, it facilitates innovation. You can have new products, new ways of building and sharing data and users, and this is a whole presentation in of itself. But when you have compute that can't be turned off, you can then build with confidence on other applications even, because those applications are running in a decentralized way and they can't be turned off, and running on modules that can't be turned off. As long as you are paying someone to provide that service, it will still be provided, and you can build on top of it in a way that hasn't ever historically been possible. This sort of analogy is the Farmville Facebook, where Farmville built a terrific ecosystem and game on top of Facebook that eventually just cut it off, right? Imagine if Facebook hadn't been able to cut it off and was just operating, and you could build anything on top of Facebook. That would be, would be a pretty compelling ecosystem of things that are hard to imagine right now. But that's what this decentralized compute type of world can be, and that's what I think is important to start to have in your head to imagine. But that's the clearest analogy. And that's why we think cloudless is the next generation. You know, this whole evolution has started in the 1980s with mainframes and desktops. And then over time, everyone has been moving to the cloud, Amazon, Google, Microsoft. It's been a long transition, but it is now the default choice to be in the cloud. And the cloudless world, we think, is the next and probably final generation of computing, where you have decentralized compute that's open, it's resilient, you can transfer from provider to provider easily. That is where this all goes. It is just a question of timing, and it's just a question of which product and which protocol is able to accomplish it first and best, and there will be many that do it. But this is where computing ultimately goes for all the reasons mentioned. So with that, we're going to do a demo, and this is a surprise piece that we're just adding in. So where is Alexey? There you are. So what we're basically doing here is bringing data to compute in real time. And the reason you want to do this is you want to solve issues. You want to solve low latency and reduce egress costs. And this is really important to do. And the Fluence decentralized compute stack is really terrific for this. And so here, Alexey, do you want to talk a little bit about what we're seeing here?
Yeah, we easily can bring compute to data with Fluence. We can deploy our pipelines, process it, and then store our data in Filecoin. So now I'm deploying all the stuff at Fluence, and we can see that we have 3 of our peers working on that. And we can run a script to seal our data. And it can be done with a small number of reusable Fluence modules and workflow in Aqua. And it works pretty fast and on decentralized networks, so we finally have with compute on decentralized cloud with data and sealing in Filecoin.
Terrific, thank you. So we can go back to the slide. So what this basically shows is that this stack that Fluence has, it's easy to deploy. And so why does this matter? It matters because you want to be able to have data owners operate in a security and in a secure environment, and that's not a default situation in Web3, right? Web3, it has a lot of benefits. Security has not historically been one. This allows that to happen, and that's thanks to the Fluence protocol and Aqua, which is terrific. And it also helps the monetization of storage and compute in a way that hasn't historically been possible. So it's another monetization engine. And so what we just showed was how easily you can deploy a compute job to write onto Filecoin. That happened very quickly. If you blinked, you missed it. But that's exactly the point, is how fast that can be. And so I just wanted to show that this is actually operating and there's real uses for it right now, which I think is important to show, and you don't see too many demos at these events. So I'm thrilled you guys were able to to witness that. And this is partners with Ramo, our co-sponsor at this event. And I hope you will see another demo that they will do and maybe go into even more detail on how it works, because it works in conjunction with the infrastructure that they built. So I hope you'll see Vuk talk about that in his talk, which is coming up. So now I'm going to shift gears and talk about, we've got this great model, but how do you secure it? And so we had to think about that a lot at Fluence. And so you have to stake our token, FLT, to provide trust. And if providers don't perform, it's slashed. And the objective here is to attract long-term providers. And so there's always 6-month vesting. You get paid for proving compute, and that payment happens over 6 months. But the design challenges are tough. If your token price goes too low, then people can't cover their costs. Not good. Token price goes too high, providers may be just interested in getting the token and not actually serving useful jobs. So you have to architect a model that actually provides some level of certainty in terms of reward for operating, but also doesn't if it goes well, disincentivize the actual performance of real compute jobs, which takes work. It takes customer service, it takes effort. So you have to solve for both problems, not just the problem of the token going down. So what we've done at Fluence is we calibrate rewards in fiat, but everything is used FLT. So at a high token price, you get, the token's at $2, your reward could be 300 FLT. But if the token price drops to 50 cents, your reward would be 1,200 FLT. So you're getting a same dollar value, but in FLT. And I think that is really important to providers, because they can then rely with much more certainty on what value they're going to achieve, and that gives them more confidence to invest in the network and to build this capacity and to serve this capacity. And so the way it works is it's for our staking is it's $12,000 worth of stake for one CPU. That's 24,000 FLT at 50 cents. We're below 50 cents now, but sort of just make the math easy. And that would then yield about $1,400 per year per staker, which is about 12%. So that is assuming a 20% delegation rate. That is how we've set it, and the rewards recalibrate every day with a max of 10% based on the FLT movements. Here's another kind of example. The investors stake that 12,000, it goes to a compute provider, they perform this proof of capacity, the reward goes to the compute provider, and then it goes back, some portion of that goes back to the staker. And that is something around this 20, we assume it's going to be around 20%, it may be higher, maybe lower, but those are the staking reward mechanisms that we think both attract capital to secure the network, because without securing the network, this doesn't work, and also provides attractive rewards for people who are providing that stake. And so that's what we have there. This is another example for the staker. If the Fluence token doubles, you make your 112% return while doing this. If it goes down by 50%, you actually don't lose 50%, you use like 38%, because your rewards kept increasing in terms of FLT over that period of time. So you actually get more rewards, and you actually capital is more protected in a downside, which I think is interesting on FLT, especially given some of the vol we've seen. And if you're going to stake, what do you care about? You care about the duration of the contract and the delegation rate. Contracts range from 1 month to 1 year, and they're not cancelable, so be sure you know whether you're signing up for a 1 month or 2 month or a year. And then also be aware of the delegation rate. 20% is great, 40% is better, and you don't know what providers will be actually offering, and so there should be a range of delegation rates. And so that is very important. In terms of the stake, it's still $12,000. That will fluctuate based on the amount of where the coin price is. So, at $2, that 6,000 FLT is required. At 50 cents, 24,000 FLT, right? So that we think also provides a stabilizing effect as well. The price falls, more stake is required, and the price rises, you then have extra FLT you can use to stake another compute, another node, another CPU if you so choose, which is, I think, also attractive. And scale, where do we want to be in terms of scale? We'd like 1,000 CPUs online in 2024. That's about $12 million worth of required stake. And next year, target I have is 50,000 CPUs. That's the size of one Amazon data center, and there are obviously a lot of those, and there's a lot of Google data centers and a lot of Microsoft data centers. That would require $600 million of FLT stake, right? That is a lot of stake required to bring that online. So those are our targets, and I think we're on track. We're going to launch public staking shortly, so that 1,000 CPU is going to be in sight, and the 50,000 we'll get more detail on next year. So with that, I'm going to announce the FLT stake race. So this is what we're doing to actually launch FLT staking. And so we've come up with a program to drive, to basically attract and to reward early community users. So we have 2 laps. Lap 1 is the ignition. It's a 4-week competition. You can complete tasks to get an NFT that allows you to be one of the first to stake in the FLT ecosystem. On top of that, there's 1 million of FLT in prizes over the 2 different laps. So you have the opportunity to both, if you participate, to earn an FLT so you can stake. You may also find someone else that wants to stake instead of you, so there may be a market to transfer that NFT to stake as well, which is another benefit. And what are the prizes? So lap 1, 500,000 in FLT for total prizes. And of those, the top 2 to 5 receive 25,000 FLT each. Each of these columns is each. So, the top, basically if you're in the top 100, you get 1,500 FLT, and every one above that basically gets more. And on top of that, there are weekly prizes for the top 20. So there are sort of mini races within each lap. So this is designed to reward community members, people that actually are participating and are doing a number of kind of the real work of growing the network and understanding what we're doing. So how do you secure your spot? Head over to fluence.network, and there's a whole number of quests you can compete in, and obviously keep checking as we're going to be updating that over time. This launches next week. Everyone who registered who's here will receive an early access QR code. So make sure you've registered so you get that early access QR code so you can participate and be one of the first people and get there right at the start gate. So excited about being able to launch this and getting our stake launched. And the important part about staking is it allows these compute providers to join the network. And so we're partnered with top-tier data centers around the world. Sort of, as others have said, we think enterprises want to have the reliability. And so we're excited to onboard the retail and consumer community, and we will, but we are starting with top-tier data centers. And these are our launch partners. And each one of these are kind of what they call class 4 data centers that are operated and used by Web 2 top-tier companies. And so the Fluence compute is happening in the most secure data centers around the world. As I mentioned, some of them are green, but they need stake in order to add their compute to the network, right? And some of them will buy stake, but many of them are not in the business of buying and staking coins. They're in the business of operating hardware. And so they're happy to give some portion of that return they get for doing that to people that are providing that capital and that stake, which are presumably from our investor community. So that stake allows this network to function. It's a security model. It wouldn't work without it. So by participating in this, you are actually ensuring trust in this network and allowing it to operate. So big picture, Fluence, cloudless, think of this as an open platform. Think of Ethereum as effectively an open platform for banking. I mean, that's kind of what it is and what it allows. The DeFi, you've seen DeFi grow tremendously. You've seen real world assets start to pick up, and you can see where Ethereum is going. We think of Fluence as analogous to that, but in the cloud. And the cloud market is absolutely enormous. I think these numbers here even understate it significantly. But we think of opening up this as opening up a cloud, an open cloud platform, and there is tremendous value for the provider or multiple providers that are able to accomplish that. So hope you can join us on this. And these are people who have backed us so far and gotten us here. So thank you to them for helping enable all the progress we've gotten to so far. So appreciate that. And then what we think about this also is we think about empowering the next wave of internet innovation. And this is a quote from Tim Berners-Lee, where, you know, we build this so that others can create things that we ourselves cannot imagine. And Tim Berners-Lee created the HTTP protocol. He did not think of Uber. He did not think of Google Maps. He did not think of Snapchat, right? He did not think of any of these applications that are used, but he knew if he created the rails, things would evolve. That's what how we think about Fluence, is enabling this open compute world where innovation can take off. So help us do that, and thank you for your time.